Let's analyze a quadratic equation in standard form. Standard form goes like this: y equals ax squared plus bx plus c, where a, b, and c are real numbers. And the only requirement here is that a is not equal to 0, because if a is 0, then x squared is gone, and we don't have a quadratic. We should notice here that in a standard form, the exponents go down from the highest to the lowest, so in descending order. So x squared, x linear, and then just a constant. Now, let's analyze our problem, which is y equals x squared plus 4x plus 3. It's already in standard form. And let's find vertex, axis of symmetry, decide whether we have a minimum or maximum and what that value is, domain, range, and roots. Now, to find domain, we don't really need to do any calculation, because we know this is a quadratic equation, quadratic function, it's a parabola, and domain is all real numbers unless we restrict it, and we didn't restrict it. So we can say x belongs to all real, or we can say anything from negative infinity to positive infinity. Okay. Now, to calculate the range, we would actually have to know where the vertex is and which way the parabola opens. So let's first figure out the vertex. The formula for the vertex, if we have a standard form of a quadratic equation, goes like this. The x of the vertex is negative b over 2a. And then y of the vertex, like any other y, if we have x, we take f of x. We plug x in. So this is going to be f over negative b over 2a. So what this really means, again, is this is the formula for the h, for the x-coordinate of the vertex. And then once we find that value, like in this case, we plug the numbers in, find the value. Whatever the result is, we plug it back into the function, and we find what that is. So we plug it back in here for x. Now, to calculate the vertex in our case, we need to first, it's a good idea to first get our a, b, and c. So our coefficients, right? A, b, and c. For this problem, we actually don't even need c, but let's just find it anyways. So a is the coefficient in front of x squared. So x squared doesn't look to have anything there, which means the coefficient is 1. Then b is in front of the linear term. So here we have 4, positive 4 plus 4 in front of x, so that's just 4. And then c is the number by itself, the constant, so it's 3 in our case. Now let's calculate our vertex. First, let's calculate the h, or the x of the vertex, which means we're going to use this formula right here. Okay, so the formula says, so h means same thing as x of the vertex. Formula says negative b over 2a. Now, the minus and the 2, they're part of the formula. And now we just need to put in our values for b and a. Value for b is 4, so we put 4 here. And then value for a is 1, so we put 1 here. So we get negative 4 divided by 2, which is negative 2. So our x of the vertex is negative 2. All we need to do now is take this negative 2 and put it back into each x in our equation. So the k of the vertex is actually y of the vertex, and it's equal to, instead of x we put negative 2, so negative 2, and then it's squared, plus 4 times, again instead of this x we put negative 2 again, and then we have plus 3 at the end. So negative 2 squared is 4, 4 times negative 2 is negative 8, and then we still have plus 3. So 4 minus 8 plus 3 is actually negative 1. So this is negative 1. It's negative 8 plus 4 plus 3, right? Negative 8 plus 7, so it's negative 1. So we know now that our vertex is negative 2 for x and negative 1 for y. So if you want to find it, if you want to graph it, it's going to be 2 units to the left and 1 unit down, right? So it's right here. So that's our vertex right there. Okay. So negative 2, negative 1. Now axis of symmetry is a vertical line, which means the equation is going to be x equals something. Vertical line that goes straight through the vertex, straight to this point right here. And if that's what it does, then it's going to hit the x coordinate, the negative 2, right? So x equal negative 2 is actually axis of symmetry. So to get the axis of symmetry from vertex, we simply say x equals the x coordinate of the vertex. Now the y coordinate of the vertex is either our min or max, because vertex is where the function makes a turn and goes the other way. So we know that that value will go right here. Now whether this is a min or max depends on whether the function opens up or it opens down. We can find that in different ways. We can graph it on a graphing calculator and see which way does it open. Or we can also look at the equation and see whether the square term is positive or negative. There is no minus in front of x squared, which means it is a positive term, which means the function is going to open up. So it's going to look like that. Well, if it's opening up, then vertex is right here, and this is the minimum. So we have a min. Now, if there was a minus in front of x here, then it would open like that, and we would have a max, right? The vertex would represent the maximum. Okay, now we have vertex, we have axis of symmetry, we have a minimum which is equal to negative 1. We already know domain. Now the range depends on whether the function opens up or down and what is the y coordinate of the vertex. So we know that y coordinate of the vertex is negative 1, right? Which happened to be our min. And it's min because the function opens up. And if it does open up, then we are going to say, well, anything from negative 1 to positive infinity. And we need to include negative 1. That's why we put the bracket. Or we can say any value of y that is greater than or equal to negative 1. Either way. Okay. Now, what could have helped in deciding whether the graph opens up or down is the constant here, which actually represents the y-intercept. And why is this a y-intercept? Well, y-intercept is when the graph hits the y-axis. And if we are on y-axis, that means x is actually equal to 0. If x is equal to 0, then 0 squared is 0, 4 times 0 is 0. So every term that has x in it will be gone, and we'll just end up with y equals to 3. So if we have y equals to 3 here, 1, 2, 3, we have a point here, and we know this is a vertex, then we definitely know that function is going to open up. Let's just get this axis of symmetry here, so we have a better idea of how symmetrical the parabola is. So this was our axis of symmetry, which is x equal to negative 1. axis of symmetry. Now, if we have an axis of symmetry and we have one point, we can always just reflect that point across the axis of symmetry, and that will help us figure out shape of the parabola and whether it opens up or down. So we should now be able to see that it actually opens up. Okay, how to find roots? Again, we could simply just graph this on a graphing calculator and then find the minimum of the function, find zeros of the function or roots of the function, whatever the software actually calls it. Let's just try to explain that. So roots in our situation here means the same thing as x-intercepts, which means the same thing as zeros, which also means solutions. So depending on which software you're using, which calculator you're using, they might call it different names, but all these names mean the same thing. So that's one way to find the roots, to graph it and then find where the graph hits the x-axis, and that would be it. Another way to do it would be to try and factor this problem here. If we factor it, factored form is actually root form, and root form will give us the roots. So let's try to factor. How would this factor? Well, x squared is by itself, so we can open two sets of parentheses and put x in each. And then we find factors of 3, which are 1 times 3. And when we add them together, gives 4. So those are actually our choices. So plus 1, plus 3. Now, if we want to find x-intercept, that means we need to be on x-axis. If we are on the x-axis, then y is equal to 0. So we simply just need to equal this to 0. If we equal it to 0, then x plus 1 and x plus 3, the right-hand side will have to be equal to 0. Well, for the right-hand side to be equal to 0, either this or that needs to be equal to 0. So let's equal it to 0. X plus 1 equal to 0, and then x plus 3 equal to 0. When we solve for x here, we get x equal to negative 1, and here we get x equal to negative 3. Those are our roots, negative 1 and negative 3. So now we have 2 more points, negative 1 right here, and then negative 3 right here, to help us graph this function. So let's now finally try to sketch it. So connect these two smoothly if possible. So that is our parabola. It doesn't look too great, but it's good enough to show the basic details. I hope you liked this video. I hope you understood it. If you did, please make sure to watch the other videos about analyzing quadratics, in which we analyze quadratics in root form and quadratics in vertex form. This video analyzes the quadratics in standard form. See you in the next video.